Yes. Hi everyone, this is Spencer reporting from Io. And what a wild place this is. Discovered in 1610 by Galileo, and about the same size as our Earth's moon back home. This is the most geologically active world in the solar system. So what would you like to know? Okay, so it's almost entirely sulfur. The atmosphere itself is very thin. Sometimes I even see volcanic plumes shoot material so high and so fast into the sky that I don't see it come down. Okay, so with sulfur, think of a sliding scale of hue from white to black. At 90 degrees Kelvin, or I should say 90 Kelvin, the surface temperature of Io, sulfur condenses to a white frost, taking up actually most of the equatorial regions of Io. Saturating to yellow, this is going to be a cooled material after volcanic deposition, usually pyroclastic plumes that settle into sediment, all across the globe. The hotter that this sulfur gets, the darker or lower its albedo will become. And this shows very true directly around the volcanoes in hot spots. You're going to see these orange and red deposits, especially around Paterae. Okay, think of like a caldera from Earth. Okay, think of a massive 1700 Kelvin hot tub where a good wholesome sulfur molecule can go and let off some steam. Maybe even get some bonding time with iron or oxygen molecules nearby. No, but the lava at that temperature serves as a catalyst in forming compounds such as sulfur dioxide that play a role in the atmosphere. You do know that 1700 Kelvin is like 1500 degrees Celsius, right? Well, at any rate, it's not hard to be around one at all times, but because these hotspots are without discretion everywhere on Io. I counted over 400 volcanoes last week, and that was just the active ones. I'm not seeing any evidence of a pattern in these formations other than, it's a global occurrence. It's Jupiter. Jupiter has an exponentially large influence on Io through tidal forces. With only a mere 440,000 kilometers separating the two on a 2-day orbital period for Io, the little moon is stretched, bulging up to 300 meters beyond its peak threshold, at its resting frame. This kind of elastic energy, applied to the entire world, manifests as heat as it dissipates into the iron and iron-rich silicates of the core and mantle. So much so that I don't even think that siderophile magma even passes through the lithosphere. Alright, so there's this buoyant layer of sulfuric sediment that I'm standing on, and that floats on a thin layer of magma that's even then further differentiated from ultramafic magma directly below that. So what I'm thinking is that the escaping heat from Io's interior is met by a ceiling of sulfuric sediment, and that has been perpetually compacting from younger and younger layers. Alright, I believe that this bottommost layer of material gets melted and mixed in with the iron and magnesium concentrations, lowering them to the point where they are recognized as having their own density. Unique from the lithophile elements above and the siderophile elements below. There's actually, I like to think that as the crust around the magma vent becomes cooler and closer to the surface, the magma will actually lose more and more of its concentration of iron to the point where it's going to be completely depleted by the time it reaches the surface. But that's okay. That iron, being lost along the way, solidifies, and I like to think reinforces the magma tubes or vents with maybe peridotite, possibly. Yes, I'd say that's a pretty good intrusive igneous rock to hypothesize. No, that's not even all. Tidal bulge causes fault thrusting on what I believe to be Io's single unbroken crustal layer. There's pushing of layers of sediment into themselves, sometimes resulting in features taller than Mount Everest. Tidal bulging also acts as a pump that speeds up the differentiation process, sucking heated material surfaceward at all times. Even Jupiter's magnetosphere interacts with Io in a really cool way. Yes way. So sulfuric material at the ceiling of the atmosphere, the thermosphere, I believe, is swept up by Jupiter's magnetosphere, ionizing and placing it onto Io's orbital track. That's probably 2 tons a second that this occurs, but it's okay because I definitely think there's enough volcanism to replace the sulfur. This phenomenon is actually called the plasma torus. It is the liquid iron interior of Io that conducts and channels the energy from the torus directly back into Jupiter, completing a circuit known as the flux tube. Remember talking about the colors, Other Spencer, of Io a few minutes ago? From white to black. Well, I didn't get to the blackened poles on the north and south sides of the world because I wanted to save the best part for last, definitely. Alright, so it is actually ionization of the sulfur molecules at the poles where the flux tube current enters and leaves the moon. Alright, like the charred ends of a wire that you just run a current through. So much energy is pumped back into Jupiter that it may be responsible for, storms like the Big Red Spot. Well, that power source is definitely starting to tap into me, I don't feel too good. I think it might be some kind of radiation sickness. That's all I really have for you here on Io. And speaking of Juno, it said something about wanting to stay back and hang out with Jupiter, so I think I should come to you about asking for a ride home. Other Spencer, it's cold up here. I mean, it smells like eggs, rotten eggs, all the time. And not to mention, I can't even find a good place to stay because every time I set up camp, a hotspot starts right under it. Hello? Hello? Hello?